Hi guys, my name is Gumbo and I'm here to present a core lecture on the introduction to modeling. And for this presentation, my overview is as follows. I will go through the introduction, model types, the importance, and into the conclusion. And on the hierarchy of models, the topic introduction to modeling actually touches all the aspects of the hierarchy of models, as you shall see during the presentation. So we ask ourselves, what is a model? And to our minds, I know that this is what a model, what type of a model, this is what type of a model comes to mind as we ask ourselves what a model is. These models, they model how clothes would look on ordinary people. And often in times we've seen that how the clothes look on the models is not really exactly what they would look on ordinary people, which brings us to what George Box was quoted saying when he said, all models are wrong but some are useful, which is a statement that we will be guiding some of our talks as we go on through this lecture. And to get a practical example of what a model is, I've taken the liberty of using model plane to depict what really a model is. So let's listen to this short video.
Boeing 747. The design and paint is incredibly exact to the real Boeing 747, but this model is radio controlled. The toy is 5.5 meters long and weighs 68 kilograms. If you're far enough away, you might think it's the real Boeing 747, as the flight takeoff and landing processes are quite similar to the real deal.
From the short video, I think we all get to understand what a model is, how it replicates what is real, and how it can be different from the real world system as we model it. Then for us to define now what a model is, I've taken this definition to be guiding this lecture, which says a model is a representation of the essential characteristics of a real world system or a situation which can be used to predict future behavior under a variety of different conditions. We then go on to ask ourselves, where is modeling applied? And then from the core lectures that have been done, we actually can say that in population studies, we can be able to use modeling to come up with the population pyramids. We can see that modeling can be used in economics to understand future trends, how monetary policies will change the financing situation. And in environmental studies, modeling has been vastly applied to understand how anthropogenic and natural climate change is affecting the environment as we know it. And from the lecture on plate tectonics, we can get to use models to understand how the interaction of plates results in physical features. And in chemistry, we can actually model things like photosynthesis to really understand what goes on in the photosynthesis process. And in the real life situations where we can actually try to get to arrest thieves, serial killers, we can model their interactions to actually find them. And these are the types of models that we have: the physical, the analog, and the symbolic, with the physical model being a real tangible model, the example of a model plane that we just saw. And the symbolic models are either tangible or abstract and basically use mathematical equations to compute the problems. And the modeling process is the process of representing the reward system in a simpler, structured way to solve the complex problems that occur in life. And to achieve this, modern civilization has adopted the use of technology in the form of computers to input these mathematical equations into them so that they can compute. This has made the modeling process much easier and efficient. The modeling process is represented in this flow diagram, where we have the problem analysis all the way through to the maintenance of the model. And I'll go on to explain each and every step of the modeling process. Starting with the problem analysis, we are going to use the not to code talk and try to explain the modeling process using that code talk. In that code talk, we learned that the problem was why is Earth habitable? And the hypothesis was synthesized from this question, which says that the Earth is habitable because it is at a right distance from the Sun. Is this true? We have to test the hypothesis. We have to create a model now to understand if this is true. So we move on to model formulation. We start to gather data, parameters, we do assumptions and laws that are actually which work on all the phenomena we are trying to find out, and we look at the variables and the units that we need to use. After that, we created an equation which speaks to the problem they want to solve. And then from then on, after creating the equation, it's time for computation. But before we compute, we have to explain what a parameter is. A parameter is a numerical or other measurable factor forming one of a set that defines a system or sets the conditions for its operations. It is a process of defining parameters. The parameterization process is when we decide on parameters to use in the model so that the model can become complete. And as we move on, as we compute the model, parameter values are computed into the model equation and solved. The equation we had created from before, we now compute it to find that if temperature, or what the temperature will be at we're using the equation that we created. If we solve for temperature, it was discovered that the Earth will be actually at minus 18 degrees Celsius, which is not applicable for humans. And after computing this model, we will go on to verify and validate it, asking ourselves, why is the problem solved right, and was the right problem solved? If problems are encountered during the model application, the verification and the validation period, we have to redo the steps. We go back to parameterization, data collection. This is the process of troubleshooting, so that we really get to understand where we went wrong and rectify it, and then rerun the model again. If we are satisfied with our model, we then go on to report on the model, where we do an analysis of the model. We look at the model design, the solution that was produced, and the results and conclusion. And from the not to code up, we concluded that the distance from the Sun is not the only factor accountable for the right temperature for Earth to be habitable. And with that, we now go on to understand that the model needs to be perfected. Some other elements are playing in this equation, and they need to be taken note of. And then this, we do it during the model maintenance. This is an ongoing process in the modeling process, where the model results are generated, and we inform the modelers on corrections to be made to the model, improvements that are necessary to make the model more robust, more efficient, and enhancement in terms of the hardware that is used, the software, and user friendliness, and so on. This is a continuous process, and it changes as new information is learned. And this modeling process is riddled with a lot of uncertainties. we know that the results of models are not exact but rather approximations, and there are many sources of uncertainty during the process, where we have uncertainty from lack of knowledge of the modelers themselves. We have data that is used especially down in southern Africa and Africa as a whole, where we do not have confidence in the data sources we have. The inherent uncertainties that the model itself comes with bring about uncertainty in the modeling process. And for us to have results which are very close to the truth, an uncertainty analysis is quite necessary in the modeling process, so that our approximation can be close to reality. The importance of modeling, I will put it in a nutshell. It's the importance of a model is for us to understand how past events happened, so that we can understand our present and be able to see into the future, predict the future using models. The models evolve with time. As time goes on, we find that the models themselves also they also change for the better. Models can change with time because of as time goes on, new information is learned, and this new information is put into the models during the model maintenance, and changes have to be made to make it better. The advancements in technology, as we have seen with mathematical models, which started as equations, but now the same equations are now being used in computers, where the computers do the computing rather than the human aspect of it. This also removes uncertainty and adds efficiency. And if you find that at times since the earth system processes are so many, if linkages can be made between different processes, then hybrid models can be produced to actually quantify the processes and link them together. The problems with modeling are that modeling are complicated for for first-time users, unexperienced users. They might actually find problems with using models. They require large volumes of data, especially in time series data, for us to have more accurate approximations. The modeling process is riddled with a lot of uncertainties, as explained before, and they give approximations rather than exact outcomes. So a lot of uncertainties rise with the use of approximation. And those ones that are more accurate, models that are more accurate and very robust, are quite expensive to use as well as to maintain. South Africa is currently developing its own climate model for use in environmental studies, and the fact that at Wits University in 1973, Pittman developed a rainfall runoff model that has been now developed into the Pittman Sparksim hydrological model, which is used extensively in Southern Africa, in South Africa as well, and it has been reported to be a robust model which is producing results that are quite good. And then to conclude, models are a tool to aid in decision making, not that they are a decision in themselves. There are many forms of models that address different real life problems. The modeling process has to be verified and validated, so that we actually ascertain the effectiveness of the model. And all models are riddled with uncertainty, and to understand future scenarios, the use of models is very important in understanding how future scenarios will be like. So Thank you for listening to my presentation. I hope it was worth your time. Thank you.